Okay, as I said in the previous video, this video will be more like a Microsoft Excel demonstration. So here is Excel. I zoomed to help you see it better. And we are going to use formulas, of course, and insert formula. You may use normal, search for normal, and then there are many. And what we are going to do here is these functions: norm.dist, norm.inv, norm.s.dist, norm.s.inv. We are going to use them all, but right now what we need is norm.s.dist. So norm means normal, of course, S means standard, and dist means distribution. So click this, double click. Then you need to put a number and cumulative true or false. First, I'm going to use true. So we are going to use cumulative distribution, and z is the value, a number that you want to calculate the cumulative probability. So for example, let's put 1. And then the answer is 0.84134. So that means actually it is a longer, much large, endless decimal, but so it cannot calculate more than this much. So it is the probability, cumulative probability smaller than 1. We just calculate, we entered 1. So that probability of standard normal distribution is smaller than 1 is 84%, 84.1344746068.5%. This is the probability smaller than 1. If you change it to, say, 2, the probability will increase to 97. So as you can change this number, probability smaller than 0 is 50%, as it should be, right? In that way, remember what we just calculate is the CDF, the cumulative distribution of a standard normal distribution. So we cannot calculate the probability, but the computer knows the function CDF. So what we need to do is we just have to input the value A. So if you put a number, then it returns the cumulative probability. So try these 5 points. I just showed you 2, 1, 0. So it should be pretty straightforward how to calculate these 5 numbers. If you are not good at Excel, do this practice, and then you must be able to find those numbers, probabilities, pretty simple. And now remember, it is cumulative probability, so 2.275 is the probability smaller than -2, and it is probability smaller than -1, smaller than 0, smaller than 1, smaller than 2. It is always defined as something probability smaller than the number. Then what is the probability greater than -1? Can you calculate this using those numbers? Right? Now this is not a computer work. You have to do it by yourself based on those informations. Right? The answer is probability greater than -1. By the way, as I said, equal to does not matter in probability. So I keep saying greater than or smaller than. So probability greater than -1 can be calculated from probability smaller than -1. Smaller than -1 is 15.866. So the other side of that probability, 100% minus this probability, is this guy, this probability. if you calculate, it is 84.134%. 100% minus probability smaller than -1. That's this one, right? So on the graph, what we would like to calculate is this guy. Probability greater than -1. This area. Color the area greater than -1 on the interval greater than -1. And if you use the symmetry, you may flip the image and calculate this area, right? So then this is smaller than 1. So greater than -1, the flip image of greater than -1 is smaller than -1. So this area is another, like it is known. It is a cumulative probability already calculated here. So if you use the symmetry, then like without looking at this, you can just simply choose this answer. So there are two different ways. If you use the cumulative distribution function approach, you may use this information to calculate this probability. Or if you try to understand it visually and use the symmetry, then you may use this information. Using the symmetry, you may understand these two areas are the same. So either way, the answer is 84. Now then, how can you calculate the probability between 2 points? That's another important question, important probability. Probability between -2 and +2 can be calculated using this probability and this probability, right? So we know that probability between A and B can be calculated as the difference in those two probabilities, those two cumulative probabilities. So subtract probability smaller than -2 from the probability smaller than 2. So we know this, we know this. We know smaller than 2 is 97%, but of them, 2.2% is smaller than -2. So take the difference, subtract. Then you get 95.450%. This is the probability between ±2%. By the way, this number it's a widely used rule of thumb approximation. So we approximate the probability between ±2 as 95%. So in standard normal distribution, 95% of outcomes are within ±2. So you are going to see this approximation quite often in the following chapters. Just so try to remember this approximation, right? So graphically, this area, this colored blue area is approximately 95%. Remember that. Okay, so far it was pretty straightforward. When I give you a number on interval or one or two numbers, then you could calculate the probability. But the next step is going the other way. Now I give you the probability. So I will give you this probability. So earlier I give you A, input A, then I'm asking you what is the output probability. But we may do the other way. I'll give you the output probability, then what is the number A that yields that probability. So given P, we are looking for A. So this is consistent with the idea of percentile. When we learned the percentile, we used the same cumulative distribution function, and this was the definition. Probability P is below the number A. Then A is P percentile. So when you calculate P percentile, you have to find the number that satisfies this equality. So mathematically, this is to find the inverse function of the CDF. Inverse function, if you know the inverse function of CDF, then you can easily find the value A. Of course, we cannot do that by hand, but computer does that. It's easy on Excel. So we are going to find those percentiles. 5 percentile, 10 percentile, 50 percentile, 90 percentile, 95 percentile. You know, right? So back to Excel. How can you find, say, 90 percentile? 90 percentile will be calculated. The formulas. Formulas insert function, and again I will search for normal and then go down. Here earlier we used norm.s.dist, but now we are going to use norm.s.inv. INV means inversion, so inverse. We are inverting the CDF function, so you may just click this. And here, there is only one entry. You just need to input the percentile you want to calculate. By the way, 90 percentile is 90%, it's for 90%, but you have to transform the percentage into like a number between 0 and 1, like 0.9. If you just enter, then you get 1.28155. Of course, you may expand it. It's a long number, more complicated number, but simply let me call this 1.28. 1.28 is 90 percentile of standard normal distribution. Similarly, you may change 0.9 into a different number, say 0.5. That will give you the median. Then, of course, it should be 0. The median is 0. Median is the mean, which is 0. And if you enter a number smaller than 0.5, then it will be a negative number. It will become smaller than the mean. So, say in this case, 30 percentile. For example, 30 percentile becomes minus 0.52. So, by changing this number, you may find different percentiles, right? So 10 percentile is minus 1.28, and 90 percentile is plus 1.28. So due to the symmetry, 10 percentile and 90 percentile are symmetric about the mean. Okay? So by changing the probability, we could find some typical percentiles. And so then let me ask you this way. What is the top 10% value of a standard normal distribution? Top 10% value. So from those results, you should be able to interpret what is top 10% value. The answer is 1.28. So 90 percentile means below this percentile there are 90%. That means above that percentile only 10%. So this is the top 10% value. Right? So this is confusing because when we say percentile, we calculate probability from the smallest to the point. But when I express top 10%, when I say top 10%, then we calculate probability from the top. So depending on the direction, on the side, which side you are calculating the probability, you may express that as 90 percentile or top 10%. So it can be confusing, but if you think about that carefully, then it shouldn't. It's quite straightforward. So this is what we get. Or right. So always keep that in mind. Remember that top 10% value is preferably statistically we prefer the cumulative distribution function approach. So convert top 10%, the probability from the top into the probability from the smallest, from the bottom, which is 100% minus that probability. So 90 percentile. So this is a better way, or the right way, when you use the CDF, when you use Excel. Okay. Then there is another conventional notation that causes confusion. So often, like lowercase z subscript alpha denotes the top alpha percent probability alpha value. So this notation calculates probability from the top. I don't like this notation, but it's convention. It's the tradition in statistics, so I cannot change the tradition. So you have to follow the notation. So this calculates probability from the top. So the top 10% value is written as subscript z subscript 0.1. So top 10% value. But when you convert that to the CDF, you have to have 1 minus alpha. This is tricky part. Subscript is alpha, but the CDF cumulative probability is 1 minus alpha, right? And then you can find it without much difficulty. So it is z subscript 0.05 or 5%, but it is top 5% value. So then what you need to find? You need to find 95 percentile from the CDF, right? That is 1.64. So the answer is 1.64, right? So it's top 5%, 1.64. And also by the symmetry, the bottom 5% is minus of it, minus 1.64. So you may use this result instead of looking at 95%. So I'm looking for top 5% value. Then another way you can calculate that is by looking at the bottom 5%, which is minus 1.64. So just drop the negative sign. That will become top 5% value. So anyways, you may use 95 percentile or bottom 5 percentile. So the answer is 1.64. It doesn't matter what you use, but you should understand at least one of them, one of the two approaches, using the symmetry or using the CDF. So, by the way, this means by the symmetry, top 5 percentile and bottom 5 percentile will, in between them, there is 90%. So 90% probability will lie between plus minus 1.64 because there is 5% on top and 5% on the bottom, respectively. So in the middle, there is 90%. We are going to use those numbers also quite often later. So also pay a little more attention to those numbers. We are going to, and this is another way to express that. 1 minus alpha probability, say 1 minus alpha probability lies between this interval. So you'd like to exclude probability alpha. And then the excluded probability alpha must split on both sides, on the top and on the bottom. So you have to find alpha over 2 from the top and also alpha over 2 from the bottom. So the interval is given by z alpha over 2, right? We are going to use this interval approximation a lot later. Like maybe if you have taken another statistics course, then you must be familiar with those numbers. We are going to use them. Okay, so far this video was like more algebraic exercise to calculate probabilities from the standard normal distribution. So we are going to extend the standard normal distribution to non-standard normal distribution. Okay, I'm going to stop here and see you in the next one. Bye. If you think your exercise is not enough, just play with Excel and play with formulas then so that you are fluent with like calculating probabilities in standard normal distribution. Okay, see you later.